star delta, all those things will done. Next, how to connect, how to do the wiring for TC drive at VFDs. Then last is PLCs. So that will be covered in module 1A. The next module is 2A module. That is PLC HMI station. In that, we'll teach how to do the configuration of PLC and HMI, how to map the addresses, create the graphics, write the logic. In logic, there are different types of programming languages. 5 different types: ladder diagram, sequential flow, equity, all those. But we teach LD ladder diagram. I know 3 out of 5. I know 3. So if you are like good with programming, C programming, then ST will be useful. So that was the concept in module 2A to learn PLC programming, HMI, configuration, screen and then different application panels. We had 13 application panels. It is not only limited to only 13. We can create a number. And we had sensor kit also. I think you are having sensor kits. Sensor.
Yes.
I think that is not equal. So that was the concept in module 2. After learning PLC and HMI, if you go to industry, the higher level programming language is Scada. In Scada, we have 2 modules, Scada Unit 1 and Scada Unit 2. So why we have introduced 2 modules means in Scada, we're communicating with the different PLC modules, different PLCs, different communications. So in this, as its name says, industrial communication and Scada. What are the industrial communications? Modbus TCP/IP, Modbus serial communication, CAN open, Ethernet IP, all the communication protocol, whatever you see in an industry. Those to accommodate those communications protocol, we are using different PLCs, and also to simulate, to replicate like a remote operation, all those things. So in this we have 2 units, Scada Unit 1 and Scada Unit 2.
For grid regulation also we are using Scada.
Which one?
Grid regulation also. Like voltage value, current value. We are assuming some voltage value, current value. Based on that, we will design a circuit in Scada.
No. So in this Scada Unit 1, we have a main PLC. We call this one as a main PLC. I'll tell you the example how to like integrate with the concept. Main PLC, power supply, CPU, and this is the communication module, NOA communication module and NOC communication module. So this will communicate for Ethernet IP, Modbus TCP/IP and NOE for Ethernet IP. So next we have drive, variable frequency drive, VFD, and serial energy meter to read the data, and HMI, 7-inch HMI, HMI JXU 3512 7-inch HMI, and next is the remote I/O, power supply, CPU, digital input, digital output, analog input, output coupler. This is in a station 1. Similarly, in station 2, we have a PLC, auxiliary PLC. So as I told you, in Scada Electric we have different PLCs. One is modular PLC and compact PLC. That PLC we call it as modular PLC. So we are placing adding the input outputs card. But whereas in compact PLC, this is fixed one. Fixed diodes, 40 T means 40 fixed. So next is remote IoT. This is, so the concept of this, we have taken an example of WTP, water treatment plant, how the water treatment plant will be there. So let us take an example of that one only. So the main PLC will be kept in a CMC, like city municipal corporation, in a city. And next we have this PLC, compact PLC. For this PLC, example of reservoir. Let us take a reservoir. From reservoir to pump the water, we need a PLC. So for that we have used this PLC, auxiliary PLC, to pump the water from the reservoir to tank. Water will pump to tank, and then reservoir, it will store the reservoir. From reservoir we need to purify the water. for purification, again we'll pump the water to some
Purified.
different place. So there, to purify that water, again we need some pump, valve, and the process like purification, chemical dosing pump, VSL. So for that we are using this PLC, remote IO to PLC. It will process all the water, like it will clean. Chemical dosing pump, CDS, we call it as CDS.
Water
If you go to any
treatments.
industry, you'll get to know like how the processing. So after cleaning the water, again it will store in one tank. From the tank,
Distribution techniques.
distribution for distribution we have a VFD. So VFD will distribute. So now in this we'll configure the first PLC. This is remote IO. This is for distribution purpose. Let us take
Final distribution.
Final distribution. Final distribution. This PLC will be there. This is operating only for pump, valve open, close, and level. For this one, here we are using IO scanning network. So we will teach not only Scada and all those things. We will teach the communication protocols, how like in the industry different communication protocols will be there. How to integrate with the PLC. So there we can see only one protocol. Here also one protocol. But here different communication protocols. So IO scanning, with the help of IO scanning, will communicate this PLC. Next, to communicate with this PLC, we use one more, that is Ethernet IP. So Ethernet IP is a different thing. So like mine is a Schneider Electric PLC, sir. Now I want to communicate with Siemens. Both the communications protocol are different. Siemens uses Profinet, Profibus. Schneider uses Modbus, TCP/IP.
Okay.
So both are not compatible. To make that compatible, we use one more protocol, that is Ethernet IP. So that
Okay.
when we will have Ethernet IP, we will have Ethernet IP, and we'll add one EDS file, electronic data sheet. So whoever designs the manufacturer will produce that data sheet.
Okay.
With the help of the data sheet, we'll connect. So that is the Ethernet IP protocol to communicate with this one. We have Schneider only because we cannot use the Siemens or
Okay,
those
okay,
things. Siemens only, but a communication protocol we are using Ethernet IP. So if you are going for Siemens or Allen Bradley, Mitsubishi, if the communication protocol says Ethernet IP, the processor will be same. That processor we are teaching in this module. So this is auxiliary PLC, and for this also we have for locally operating, we have this HMI.
Okay.
For this raw water intake, for taking the water like from reservoir, pumping the water to tank, I'll operate from this HMI. Similarly, for purification, that is water purification plant, that one. So, this will operate from this.
So we the PFD also you are operating here.
There are. So, I'll integrate, like I'll connect these two with the Ethernet cable, because it is a simulation, sir.
Okay, I understand.
So that's why we are using it. So now I'll explain operation.
This toolkit is best suitable for water treatment plant.
Not best, sir.
For
Example.
this example,
Yeah.
example.
You can create anything. So first I'll put locally, sir. All are in locally manual. And here also I'll put local and manual. Okay, sir. Now I have to start the pump from the reservoir.
Okay.
Start the from reservoir. Check, this is the water distribution.
Okay.
So distribution is not there. Purification. One more thing is, for communicating with VFD, we are using a canonical communication, different communication protocol. This cable is connected here, main PLC. And read the data of serial communication. We are read the data of energy meter. We are using a serial communication. So these data I'll read here in HMI. So now I'll start the pump from locally. Okay. For locally, see here we have two motors, one main and standby. Locally, I started HM. the water started to fill in the tank. Now this is, we can see the main pump winding temperature. We have used temperature sensors to measure the temperature. The temperature is panel temperature. That thermocouple we have put it in a temperature. Panel. So now one motor is we have started. Here these are the simulations. Now you can see there is a level. Are you able to see any level?
6.5, yeah.
Level? Increasing?
Yeah, it increases.
Okay. So when I started the pump, the water started
Not
filling
overflowing.
the tank and the
Okay.
tank level increases. Oh, sorry, that is different. Okay, it will fill the tank to, water will fill the
It's a
tank.
water purification.
Yeah, water will fill the tank. Here you can see for water here we have two digital inputs, high level and low level. This is low level input, this is high level. We don't have tank and sensors. With the help of push button we are simulating. So this is high level. Okay. Fill the tank. Next comes part of cleaning the water. For cleaning the water, again I'll start this one. Series, that is chemical dosing pump. Chemical dosing system we call it. Next is the valve, mirror valve. When we open the Scada screen, we will get to know. So this is now the water. For water, we have simulation this one. You can see, ma'am, there is 99% something is there.
No, it's reducing.
It is reducing.
So with the help of this potentiometer, we are simulating.
Oh, yeah. Oh. The valve is always in open state. If it is below low level, the valve closes. Like that only.
I'll let you.
Okay, sir.
So now we are running in the manual.
Oh.
Everything in the manual. Okay, tank is full. Now we can start the pump to distribute the water. To distribute the water, if I start this one, it won't start because we have put the interlock. If demand is there, then only we can able to start the pump. For demand valve, I use these lamps to open the valve and start. You can see the speed. Answer. This is a manual operation. Everything in a manual. So now I'll put it in a auto mode, local auto mode. Yes, change. Auto. So local auto mode.
Another one.